Today you are going to see about line symmetry and rotational symmetry. We saw line symmetry and rotational symmetry separately. Now we are going to see about line and rotational symmetry in a single figure. Going to the exercise 14.3. Name any two figures that have both line symmetry and rotational symmetry. So you have to find out two figures which has got both line symmetry as well as rotational symmetry. Equilateral triangle and regular hexagon. As I told you, equilateral triangle, all the three sides are equal, and when you rotate it, you will get order to be 3. Same way the line of symmetry will also be 3. Regular hexagon, you can take any hexagon. Regular itself means that all the sides are equal. Whether you take pentagon, 5 sides are equal. Heptagon, 6 sides. Hexagon, 7 sides. Octagon, 8 sides. Pentagon, 5 sides. Hexagon, 6 sides. Heptagon, 7 sides. And octagon, 8 sides. So all will have the line of symmetry based on their sides, and the order will also be the same. So the pentagon line of symmetry will be 5, and the rotational symmetry will also be, order will also be 5. Then the next question. Draw wherever possible a rough sketch of a triangle with both line and rotational symmetry of more than 1. So he is asking you to draw a figure or a triangle which has got a line and rotational symmetry of order more than 1. So I am going to say take the equilateral triangle, the same thing which I have taken it for the previous sum. Equilateral triangle where all the three sides are equal. Therefore my line of symmetry will be 3, and the rotational symmetry order will also be 3. Here I have drawn the picture of an equilateral triangle wherein the line of symmetry is 3, and I am rotating it by 120 degree. Since the total rotation is 360 degree, you cannot rotate for a triangle 90, 180, 270 and 360. Since you have got only 3 sides, you have to rotate it by 120 degree. So 120 degree, again it becomes 120 degree, and the last comes to be 120 degree. So my order will be 3. So rotational symmetry of order 3. Then second and third sum I have given it as a homework. Now fourth sum. A quadrilateral with a line symmetry but not a rotational symmetry of order more than 1. So you have to find out a quadrilateral which has got only the line symmetry but no rotational symmetry of order more than 1. So this picture is of a kite. A kite is a quadrilateral which has only one line of symmetry and no rotational symmetry of order more than 1. Going to the sixth question. After rotating by 60 degree about a center, a figure looks exactly the same as its original position. At what other angles will this happen for the figure? So he is asking, when you are going to rotate a figure, any figure by 60 degree, angle 60 degree from the center, when will the figure look exactly the same as its original figure? So what are the other angles where you can find the original figure? So this is going to be angle 60 degree. Okay. Now when I again rotate it, I will get another 60 degree which is 120 degree. Then when I again rotate it, I will get it as another 60 degree which is 180 degree. When again I rotate it, I will get another angle of 60 degree which is 240 degree. Then a complete one, (360 degree). So you can observe that if a figure, children, after 240 it is 300, then it is 360 degree, one complete rotation. So for every 60 degree angle, the figure will look at the original as the original figure. So the figure looks symmetrical or rotating by 60 degree. It will look symmetrical by what are the other angles they have asked. It is 120 degree, 180 degree, 240 degree, 360, 300 degree and 360 degree. In other simple words, it is the multiples of 60 degree. Seventh question. Can we have a rotational symmetry of order more than 1 whose angle of rotation is 45 degree? So he is asking you to find out the rotational symmetry of order. The order has to be more than 1 and the angle is given to you as 45 degree. Now, how to find it? total complete revolution is 360 degree. So you have to take the angle whichever is given and find out whether that angle is a factor of 360 degree. So I am just finding out, I am dividing the 45 degree, 360 degree by 45 degree. When I divide it, I get the answer to be 8. So 45 is a factor of 360. So now my order is 8, 8. You know the formula, I believe, for finding out the order and for finding out the angle. When the angle is given, you will divide it by the order. When the order is given, you will divide it by the angle. So he's asking you to find the order. That's why I have divided by the angle and found out the order. Now 17 degree, that is the best way of doing it, children. The angle is given, you divide it by the angle and find out the order. Next question, 17 degree. 17 degree is not divisible by 360 is not divisible by 17. So the 17 is not a factor, and so you cannot find out the order. So with that, we have finished the symmetry chapter, children. Homework I will post you. Thank you.